Hi, and welcome back. So we want to look at sorting algorithms, and we're going to look at 4 sort algorithms: quick sort, merge sort, selection sort, and insertion sort. And of these 4 algorithms, quick sort is the one that gives students the biggest problems in terms of application, like in exams and so forth. So yeah, we're going to look at this one. And pretty much it uses a divide and conquer technique, more like your binary search, but this one is sorting, which means it partitions your list into sub-lists, and it keeps on partitioning, and as it partitions, it sorts. That's how it works. And you know, if we sort of preempt and talk about the selection sort and quick sort algorithms, the big O's of selection and insertion sort are what, n squared, I think, which means they are very inefficient, and the quick sort algorithms obviously gives you n log n, which is much more efficient. But the challenge with the quick sort is the worst case scenario can still be as inefficient as the other algorithms, which will lead us to talk about the merge sort, which is always n log n, hence more efficient. So the worst case means that, you know, it can happen that you can do a quick sort and it performs and the running time is n squared. Depending on the values in the array, the positioning and the pivots and so forth, that can be the case. But we want to discuss how it works, how you apply the quicksort algorithm. And in most cases, we've got what is referred to as the partition algorithm. And this algorithm is what is used to divide the list into sub-lists. Like you start off with one list and then you apply this algorithm, then you end up with 2 lists. And then you apply this algorithm on the sub-list, and then you keep doing that until everything is sorted. And this algorithm uses a pivot and what we refer to as small index variables. So this is obviously an extract. This is an extract from the textbook, so you can go and read more on the quicksort algorithm. But we are going to be using the pivot, which is what we then use to partition, using also what is referred to as the small index. So a pivot is a value that we pick from the list, and at the end of this partition algorithm, the end result is that we want all numbers or elements that are less than the pivot to be sitting on the left side of the pivot, and all items that are greater than the pivot to be sitting on the right side of the pivot. And that's how we partition, with the pivot in between, which means we pick a pivot and we run the partition algorithm, and once it's done, all items that are less than the pivot will be on the left side of the pivot, and all items that are on the right side of the pivot will be on the right side of the pivot. But it's not just a matter of selecting everything less than the pivot and putting those things on the left, and then selecting everything greater and putting those on the right. No, it's an algorithm, so you have to actually do it according to the algorithm. And once you have applied your partition algorithm, then you know you've done it right. If you look at the results and you see your pivot, and you look at the left sublist and you see that all items are less than the pivot, and you look at the right sublist and you see that all items are greater than the pivot. All right, so let's do an example. That is the easiest way to explain this partition procedure, and then we see how it works. So the first step of the partition procedure is to pick a pivot. So when we start, I'm just going to replicate these elements and put them here as they are, because this is our list unchanged when we start, which means we have 45, 82, 25, 94, 50, 60, 78, 32, 92. So this is before we've done anything. So we are going to be updating this list as we apply the partition procedure and see how we apply it. But what I want to do here, which is the most important thing, is to apply the partition procedure. And you have to follow me very closely here, because this is where people get lost. Right, and I'm going to try to be as clear as I can be, and be slow also, so that we can move together on this one, because again, this is where the confusion is. When you start with your partition procedure, you want to select a pivot, right? So step number 1, let's select a pivot. And selecting a pivot, usually they say use the mid element as the pivot. And usually your mid element is just first index plus last index over 2, like you do with the binary search algorithm, which means in this case, this is my first index, this is my last index, so it's 0 plus 8 over 2. So my mid is going to be 0 plus 8 over 2, which is first plus last over 2. And this gives me index number 4 as my pivot, which in this case is 50. So I have my pivot, okay? So in this case, pivot is 50, right? Now, step number 2 is you need to swap the pivot and the first item, which means you swap the pivot and the first item in your list. So once you have done that, you're going to have 50 sitting here as your first item. Then you have 82, 25, 94. Then now you have 45 here because these two have been swapped. Then you still have 60, 78, 32, 92. So this is after you have swapped your first item in your pivot. So if I put my lines here, it means my list now looks like this, right? There. So first item, pick your pivot, which in most cases is your mid item. Second step, swap your pivot and the first item, which means here is my pivot. So remember, I said we use what is referred to as the pivot, which is this, and small index. I'm going to use SI for small index. And to make it even simpler, I'm just going to use an arrow to represent where small index is. And in this case, my small index is going to start off here at the first item. So what is this small index item? What is this variable small index? So small index is a variable that is pointing at the last item in this collection that you found, which is less than the pivot. What do I mean? We are going to start looping, starting from the second item. So in other words, there is like a line sitting here that is separating our pivot from the rest of the array or from the rest of the list. And we are going to start looping from this second item going forward until we reach the end of the array. And as we loop through this list, starting from the second item, small index is going to be the last number that we found here, which is less than the pivot. And it's not just that. And to explain, let's apply the algorithm. So you start looping from 82 here. And as you loop, you compare 82 and the pivot. And in other words, you're going to loop through all these numbers. And as you loop, you are going to compare these numbers with your pivot, right? And what you do, and this is where you need to be careful. If the number that you're looking at is less than the pivot, then you shift small index by 1 to the right. And then you swap the current number with the current element at small index. Let's apply this. Is 82 less than the pivot? No, it's not. So if it's not less than the pivot, we ignore and move on to the next item, which means in this case, I move on to the next item, which is 25. So that means I am now here. So the only time we are worried about shifting small index is if the current item is less than the pivot. If it's not less, just move on, okay? You do nothing, just move on. So we move on to this item now, 25, and then we say, okay, we are now here, right? This is our current element. Is this less than the pivot? Yes. So this is what you do. If the current item is less than the pivot, these are very simple steps. Apply them as I'm saying them. Shift small index by 1 to the right, which means your small index shifts to the right, and it comes here, right? That means it's no longer here. So if the item is less than the pivot, step 1, shift your small index to the right, right? So let me just try and write this down. If element is less than the pivot, you're going to do two things. Number 1, shift your small index to the right. Step number 2, swap the item at your small index with current item. And then you keep looping. These are the 2 steps we are going to be talking about over and over and over again. And this is where people get confused, right? We are still on step number 2. Remember, we're going to go to step number 3 once we are done with this whole step. So we have found that 25 is less than the pivot. Therefore, we shifted our small index by 1 to the right. Small index is now here. And then we swap the item at small index with the item where we are. Sometimes this can be the same element, which means the swap happens, but nothing changes. But in this case, we are going to swap. This here is going to become 25. This here is going to become 82. Okay? Then we keep on moving. We go to 94, right? Is 94 less than the pivot? No, it's not, which means we move to the next item, which is 45, right? And then we say, is 45 less than the pivot? And the answer is yes, which means we are here, remember? If it's less than the pivot, what do? Shift small index to the right by 1, which means our small index is going to be shifted from where it is, which is here. So we shift it by 1 to here. So this requires practice so that you can do it faster. And once we have shifted it, what do? We swap the current item with small index, which means now we are swapping the current item here, which is 82, with 45. So now we've got 45 sitting here, and we've got 82 sitting here. Let me just write it at the bottom here. And now 82 is now here. And then we continue. We were here, now we go here. Is 60 less than the pivot? No, so we move on. Is 78 less than the pivot? No, we move on. Is 32 less than the pivot? Yes. So what happens? Shift your small index to the right by 1 and swap with the current item, which is 32. So remember, we are here. So what I'm going to do now is shift my small index by 1 to the right. So small index moves and goes to the right, which means it's now here. We swap 94 with 32, which means cancel that. 32 comes here. And we cancel that 32 there. And 94 comes here. And then we move on. 92. Is 92 less than the pivot? No, it's not. And we are done because we've gone through everything. So let me repeat this. Swap your pivot with the first item. Done. And then we draw a line. We are starting here. We start comparing these items with the pivot. And for each item that we find which is less than the pivot, shift your small index, swap with the current item. For every item that we find which is less than the pivot, shift your small index, swap with the pivot. Once we are done, it means if I rewrite this whole collection here, it now looks like this. We've got 50 here, 25 here, 45 here, 32 here, 82 here, 60, 78, 94, 92. This is what it looks like if I just rewrite it, right? And the most important thing that I want you to take note of here is the position of your small index. Here, your small index is here. So in other words, our small index is right here. This is where our small index is. And our pivot is still here, right? The last step is that you then swap your small index with your pivot. So where your small index is, swap that with the pivot. That's step number 3. which means your 32 comes here, your 50 goes here. So if I rewrite these numbers, now I have 32 sitting here, 25, 45. Now my 50 is now here, and I have 82, 60, 78, 94, 92. Here's my list. And which one was my pivot? Remember, 50 was my pivot, which I've just swapped with small index, and therefore here is my pivot. And if you want to check if you've done this correctly, look at the numbers on your left, look at the numbers on your right. All the numbers on the right must be greater or equal to your pivot, right? Greater or equal. All the numbers on your left must be less than your pivot. That's how you know you have successfully partitioned your list, which means in this case, I can then say after the code, my partition procedure, I now have 32 sitting here, 25 sitting here, 45 sitting here, 50 sitting here, 82, 60, 78, 94, 92, and this here is my pivot. So that means we have successfully partitioned this array into two lists, the left side and the right side. And then we repeat this procedure for the left and for the right, starting with the left. The same exact procedure. So I'm going to wipe out everything here, and we walk through these steps again, which means, and this is why you need to practice quicksort, because it really takes a while to get used to doing these steps over and over again. So let's forget about all of this that we've just looked at and redo it with that array with 3 items, right? So I'm going to wipe this clean and let's start again. Okay, so now we are starting off with 32, 25, 45, right? And we want to identify our pivot. Pivot equals first plus last over 2. This is index number 0, 1, 2. So 0 plus 2, 2 over 2, 1. So our pivot is index number 1, which is index number 1, that's 25. Right, step number 1, swap your pivot with the first item. So these two here are swapped, which means I have 25 here, and I have 32 here, 45 here. There goes my line. My small index is here, and this is also my pivot. Then I start comparing from here going forward. Okay, then I say, is this less than the pivot? No, ignore. Is this less than the pivot? No, ignore, and I'm done. Step number 3, swap your pivot with small index. Well, nothing changed. So my pivot and small index are still here. So I swap, nothing changes. And guess what? Step number 3, I have partitioned my array here. Here's my pivot. Here's my right sublist. Here there's no left sublist. And if you check, everything on the right of my pivot is greater than the pivot. Therefore, I've partitioned and I've got this sublist, which means I can write here and say, after partitioning this sublist here, I now have 25 sitting here, 32 sitting here, 45 sitting here. The rest is still the same. Remember, 82, 60, 78, 94, 92. And for this sublist, my pivot here was 25. So I would sort of like write my answer like this. And I know that I was partitioning this sublist here, right? And now I need to go and apply the quicksort now on the right sublist, because remember we partitioned, now we've got the right. So we need to do our quicksort on the right array. But here's a trick that you can use. Okay, let's redo our quicksort on this array of 2 items and see how you can save a little bit of time if you're only left with 2 items. So you have 32 and 45. And I'm saying if you only have 2 items left, do not waste your time doing the whole partition procedure because you know exactly the outcome. What is going to be your pivot in this case? Index number 0, index number 1, 0 plus 1, 1 over 2, 0. So your pivot is going to be index number 0, which means your pivot is going to be 32. You only have 2 items left. You know that after your partition procedure, items greater than 32 would be on the right of 32, and items less would be on the left. Here in this case, 45 is greater, which means 45 will remain on the right side of 32. So if I partition this part here, so I still have 25 here, I still have 50 here, 82 here, 60 here, 78 here, 94 here, 92 here. If I apply my quicksort here with 32 as my pivot, I'm going to have 32 on the left and 45 on the right of 32. So I don't have to like waste time and redo the whole procedure and all of that. I can just write it down. So I can say I'm going to have my 32 on the left and my 45 on the right. And once there is only one item left on the right side of your last partition, you are done. Which means if you check here, we partitioned and we had these two sub-arrays, this left side and this right side here. After partitioning the left side, we ended up with this sub-array, which we partitioned, and we were left with only one item. So we are done with the left side. Now we're going to apply the quicksort algorithm on this right sub-array that we have not yet partitioned, which means your left side is pretty much going to remain exactly like this. You're always going to have your 25 here, your 32 here, your 45 here, your 50 here. But now the focus is on the right sub-array. And we apply again the quicksort algorithm. So we go back there and let's just wipe this out and reapply the quicksort algorithm on these 5 elements. And in the exam, they don't normally give you very large lists. Or if they give you a list like this one, they can say, well, just do the first 2 sometimes. But let's go. We have 82, we have 60, 78, 94, 92. So this is what we have, right? And we need to find our pivot. In this case, index number 0, 1, 2, 3, first plus last over 2, 3 plus 0, 3 plus 0 over 2, get 1, which means, what did I do here? Sorry. 0, 1, 2, 3, 4. 4 plus 0 over 2, index 2 becomes our pivot, and you swap your pivot with your first item. So you've got 78 sitting here, and you've got 60. Now your 82 is now sitting there because you swapped. Your 94 is there, your 92 is here, your small index is there. So you can see you can get significantly faster if you just keep practicing. So I'm going to start here. 60, is 60 less than the pivot? Yes, it is. Therefore, let's shift small index and let's swap. But well, it's the same number. So if we swap, nothing changes. We go to the next number. Is 82 less than the pivot? No, it's not. Is 94 less than the pivot? No, it's not. Is 92 less than the pivot? No, it's not. Therefore, we are done. Last step, swap your pivot with small index, which means your small index, your 60 goes here, your pivot goes there, and you've got 82 here, 94 there, 92 there. This was your pivot, right? And you can see you have partitioned. So in other words, we can say now we have 60 on the left, 78, which is our pivot, and on the right we have 82, 94, 92. But because we only have one item on the left, there's nothing to partition. We only partition if we have at least 2 items. So that means we need to repeat our partition now for the right side, which is these 3 items here. And obviously this 60 is only one item, so there's no need to repeat. So we apply the quicksort again for 82, 94, and 92. So we go back here. Let's wipe this clean again. So in the exam, they don't want to see all this partition procedure working. They only care about the end result. This stuff here doesn't matter how messy it gets. They don't care. Okay. So we can then repeat and say we have 82, 94, 92. Obviously, index 0, 1, 2 over 1, we get 1. This becomes our pivot, which we then swap with our index, with our first item. So now we have 94 on the first index. We have 82 here. We've got 92 here. Our small index is here. We start comparing from here. Is 82 less than the pivot? Yes, it is. Therefore, we shift our small index and we swap. But if we swap here, it's the same number, so nothing changes. We go to the next item. Is it less than the pivot? Yes, it is. So we shift our small index and we swap, but it's the same number, so nothing changes. And then last step, now swap your pivot with small index, which means 92 comes here, 82 is here, 94 is here, and that was a pivot, remember? Which means we can say, oh, we have partitioned. Now 94 is here, which is our pivot. And we now have 92 and 82. The rest of the numbers are still exactly the same, 45, 50, 60, 78. But we need to repeat our partition for these two numbers, 92 and 82. And remember, I said if you have only two numbers, 92 and 82, and you want to apply quicksort here, choose your pivot, 0, 1, 1 plus 0 over 2, 0. So this is your pivot. And after your partition procedure, all numbers less than the pivot are going to be on the left side of the pivot, and all numbers greater will be on the right, which means in this case, 82 is going to be on the left side of your pivot, which is 92. So that's how they become, which means after partitioning these two here, you have 82 on the left of 92, which is your pivot. And the rest is still the same. 45, 50, 60, 78, 94. And because everything has now been partitioned, you are done. So this is what they want to see when they say apply the quicksort algorithm and show us every step of the partition procedure. This one, I just put it there so that you can see how it changes until the whole array is sorted. So the quicksort algorithm really requires a lot of time to practice, and it's 3 simple steps. Number 1, identify your pivot. Number 2, swap your pivot with the first item, then start looking from the second item. And for every item that is less than your pivot, shift your small index and then swap with the current item. Keep doing that. So really, you can just repeat this procedure with me slowly, try and follow up on paper and see if you can catch up with what I'm doing. Let's look at another example of like an actual exam type question on quicksort algorithm. This one says, consider the following array of integers. Sort the array using insertion sort. So I won't do this one. For this, you should go and look at the insertion sort algorithm. I want to do 5.2, which says, apply the quicksort algorithm and show the array, the state of the array after each call to the partition procedure. So when we start, we have 2, 8, 4, 3, 6, 4, right? So index number 0, 1, 2, 3, 4, 5 over 2, we get 2, which means 2 becomes our pivot. So first step is you swap your pivot with the first item, which means you get 4 here. Then we have 8 here, then 2, then 3, then 6, then 4. Our small index is here. Then we start comparing from 8. Is it less than the pivot? No, it's not. Okay, skip. Is 2 less than the pivot? Yes. So shift your small index and then swap your current item with your small index, which means 8 comes here and 2 goes there. You go to 3. Is 3 less than the pivot? Yes, it is, which means you shift your small index. You swap the current item with where your small index is, which means you swap 8 with 3. Go to the next item, 6. Is it less than the pivot? No. Okay, go ahead. 4. Is 4 less than the pivot? No. Only when it's less. If it's equal, then no, right? Because all items greater or equal must be on the right. So if 4 is not less than the pivot, then you just ignore. After this, you then swap your pivot with your small index, and your small index is here. Because now you've got 4, 2, 3, 8, 6, 4. So your small index is here, which means you swap your 4 with your 2. Or if I rewrite this just for the sake of clarity, I'm saying we now have 4, 2, 3, 8, 6, 4. Your small index is here. So you then swap your pivot with your small index, which means you end up with 3, 2, 4, 8, 6, 4, and there's your pivot. As you can see, all numbers less are on the left, all numbers greater or equal are on the right, which means our first call to the partition procedure leaves us with 3, 2, 4, which is our pivot, 8, 6, 4. So we repeat for these 2 here, but again, remember what I told you, if you only have these 2 items, then there's no need to waste time because your pivot is going to be 1 over 2, which is 0. So this is going to be your pivot. And after you quote your partition procedure, all numbers less than the pivot will be on the left. So it will look like this, which means now you just have to put 2 here, 3 here, which is your pivot. And the rest are still the same. And then now we repeat our partition procedure for the right subarray, which is 8, 6, and 4, right? And just wipe this. Okay, so now we repeat for the right subarray, which is this one with 8, 6, and 4. And again, what we have to do here, 8, 6, 4. Your pivot is obviously going to be 6. Then you swap your pivot with your first item. Now you end up with 6, 6, 8, 4. Is 8 less than the pivot? No, it's not. Okay, move on. Is 4 less than the pivot? Yes. So shift your small index and then swap, which means your 4 comes here. Your 8 goes there. Here's your small index. Now you're done. Swap your small index with your pivot, which means you swap these 2 here. So 4 goes here, 6 goes here, gives your pivot, and your 8 is there. And you have partition, which means now you have 2, 3, 4. And when you partition there, you've got 6 as your pivot. You've got 4 on the left, and you have 8 on the right. And because there's only one item on the left and one item on the right, you are actually done. That's how you would do your quicksort algorithm in this case. It takes practice, and just understand the steps that I'm giving you without compromising them or trying to be clever. It's literally exactly as it is. Right? Yeah. And let me not make it worse. Here's another question. This one says that you've got these items in an array, do selection sort. I won't touch that one. This list is to be sorted using the quicksort algorithm with the middle element as the pivot. Show the resulting list after the first and second calls to the partition procedure. So in the exam, I would skip such a question as this one because I'm not going to spend this time to get this 1 mark. I would sort of leave it and come back when I have time, because sometimes people waste time on things that are not worth. So this 1 mark for this kind of a question was not really worth it. So practically, I would leave this question, finish off everything else. And if I really have time, I can come back and get this 1 mark. Because you might lose more marks trying to get 1 mark, because you know you can do it, it's just going to take time. But anyway, so here are your numbers. So if we do our first call to the partition procedure here, how many numbers do we have? We've got, so our index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means index number 5 becomes your pivot, 0, 1, 2, 3, 4, 5, 30. So I'm going to swap 30 with the first item, 28, which means after doing that, I'm going to have 30 here as my first item, and my small index is here. I'm going to have 18 there, 21, 10, 25. Now, instead of 30, I have 28, because remember, I have swapped. Then I have 12, 71, 32, 58, 15. And then you start comparing. Is 18 less than the pivot? Yes. So shift your small index and swap. It's the same number, so nothing changes. You go to the next one. Is 21 less than the pivot? Yes, it is. Shift your small index and swap. It's the same number, nothing changes. Is 10 less than the pivot? Yes. Shift your small index and swap. It's the same number, nothing changes. Is 25 less than the pivot? Yes. Shift your small index and swap. It's the same number, nothing changes. Is 28 less than the pivot? Yes. Shift your small index and swap. Nothing changes. Is 12 less than the pivot? Yes. Shift your small index and swap. Nothing changes. Is 71 less than the pivot? No. Okay, move on. Is 32 less than the pivot? No. Okay, move on. Is 58 less than the pivot? No. Okay, move on. Is 15 less? Yes. So shift your small index and swap. So you're here, you swap with 15, which means 15 goes here, 71 goes there. Then eventually you swap your small index with your pivot, which means you're going to end up with 15 here, then 18, 21, 10, 25, 28, 12, 30, 32, 58, 71. You highlight your pivot. And as you can see, all numbers on the left are less than the pivot, and all numbers on the right are greater than the pivot. Then you repeat again for your subarray, which is the second call. to your partition procedure, which means in this case, you are now repeating this for 15, 18, 21, 10, 25, 28, 12. And you've got 0, 1, 2, 3, 4, 5, 6 over 2, 3, 0, 1, 2, 3. That becomes your pivot, which means you're going to swap 10 here with 15. So you've got 10 there. Then you have 18, 21. Now there's 15 here, 25 there, 28 there, 12 there. My small index is here. I start looping. Is 18 less than 10? No. Is 21 less than 10? No. Is 15 less than 10? No. No, no, no. So all these are all greater than your pivot, which means at the end of the day, you swap your small index with your pivot. Nothing changes. So I'm done. So 10 stays there. Then you have 18 there, 21, 15, 25, 28, and 12. And there's your pivot. So if you write everything together, that means here I'm putting 10, 18, 21, 15, 25, 28, 12. Then these are still exactly as they are. And my pivot here is 10. So these would be the first two calls to the partition procedure. Maybe the last one I might want to talk about is here. Both the merge sort and quicksort algorithms sort a list using by partitioning the list. Explain how the merge sort algorithm differs from a quicksort algorithm in partitioning the list. So the quicksort algorithm, when partitioning the list, uses a pivot, and it partitions the list such that all numbers less than the pivot are all numbers less than the pivot are on the left, and all numbers greater than the pivot are on the other sublist, which is on the right. Whereas with the merge sort algorithm, the list is split into just two nearly equal halves. That's it. That's how it splits. Just goes half, done, split. That's how the merge sort works. So yeah, quicksort uses a pivot, and partitions using a pivot by putting items less than the pivot on one list and items greater or equal than the pivot on the other list. And merge sort just splits the array into nearly equal halves. So we'll talk about the merge sort in the next lesson. But as far as the quicksort is concerned, you just have to practice quicksort and keep on practicing quicksort. Maybe let's look at one last example on quicksort here, which is 18923. They say use the quicksort algorithm. So you've got 18923. How many items do you have? Or your index, the last index is 0, 1, 2, 3, 4. So the last index is 4. So 0 plus 4, 2, 0, 1, 2. This becomes your pivot. So pretty much last index over 2, right? So swap your pivot with the first item. Now you end up with, let me write this here. You end up with 9 there. With your small index there, you've got 8. Now your 1 is here. Your 2 is there and your 3 is there. Okay? Because you swapped these two. So there. Then you start comparing from the second item. Is 8 less than the pivot? Yes. Shift small index and swap. Nothing changes. Is 1 less than the pivot? Yes. Shift small index and swap. This will keep happening until you get to the end. Let me just do it step by step. Is 2 less than the pivot? Yes. Shift your small index and swap. Is 3 less than the pivot? Yes. Shift your small index and swap, which means you remember you are swapping where small index now is with the current number, but it's the same number. And once you are done, you swap your small index with your pivot, which means you end up with 3 here, 8 here, 1 here, 2 here, 2 there, 9 there. That's your pivot. So our final answer is going to be 3, 8, 1, 2, 9 is our pivot. We repeat for this list. So we now have 3, 8, 1, 2. Obviously, your last index 0, 1, 2, 3, 3 over 2, 1, 0, 1. That becomes your pivot. So we swap the pivot with the first item. So this becomes our 8 with our small index there. 3 is here, 1 is here, 2 is there. Is 3 less than the pivot? Yes, shift and swap. Is 1 less? Yes, shift and swap. Is 2 less? Yes, shift and swap. And eventually swap your small index with the first with your pivot. Now you end up with 2, 3, 1, 8, which is your pivot. So again, you have partitioned. Now you have 2 here, 3 here, 1 here, 8 here, which is your pivot, and 9. Now you repeat for 2, 3, and 1. So I've got 2 here, 3 here, and 1. Obviously, 3 becomes my pivot, so I swap these 2. I've got 3 here with my small index. I've got 2 there, I've got 1 there. Is 2 less than the pivot? Yes. So you shift and swap. Is 1 less than the pivot? Yes. So you shift and swap. And eventually you swap your small index with your pivot, which means you end up with 1 here, 2 here, 3 here, which is your pivot. So now we go 1, 2, 3. There's my pivot. I still have 8 and 9 there. I repeat for 1 and 2. And if you have 2 items, obviously 0 index, 1 index there, 0 plus 1, 1 over 2, 0. This becomes your pivot. And once we have applied your quicksort algorithm, items or numbers greater than 1 will be on the right, which means 1 is going to remain on the left and 2 is going to be on the right. So I can then say, well, I have partitioned 1 here on the left, which is my pivot, 2 on the right, 3, 8, 9, and everything has been partitioned. So that's how you can quickly do this in an exam scenario. And it shouldn't take much time if you have practiced the quicksort algorithm enough and you know exactly what to do. So, yep, go and repeat this video. Try and move slowly with me and try and apply the steps as we are doing them together. Otherwise, feel free to bring questions in our live classes and then we can discuss this further if you are finding it difficult. But I really hope that this suffices and you understand how to apply the quicksort algorithm every time you have to do it. So that's it for this one. I'll see you again in the next video. We're going to talk about the merge sort algorithm. But the quicksort one, if it's of any comfort, is actually the most complicated. The rest of the algorithms, in terms of applying them in an exam context, they are very, very easy. It won't take you more than, it won't take you a minute. It's really easy. But this one needs practice. Okay, that's it for me. I will see you again in the next one. Cheers.